Let's take the next one, that is question number 69. Set of exhaustive values of x for which the given function is monotonically increasing. So what is required for being monotonically increasing? We need to go for the derivative of it. Let's find the derivative of the given function. This is 3 cos x plus 3x square plus 4. Now when you look at the possible values for this term, 3x square plus 4, obviously it is always greater than or equal to 4. Cos x, it can take values between -1 and 1. So overall function, yes, it is always positive, meaning the derivative is always positive. So we can clearly conclude here this function is monotonically increasing for every real value of x. Hence the correct answer is option number 1. I'm sure this is clear. Let's move on to the next one, that is question number 70. Integral e to the power x cube dx is equal to, simple integration, we have to apply by parts. So let's go for this solution. I equals, what we do, we simply write x cube into ex, because I'm applying successively, because we have e to the power x function multiplied with a polynomial. So what we need to do here, 3x square into ex, that is derivative of first function, integral of second, plus derivative of this function, that is 6x, integral of the other one, that is ex, minus derivative of this term, that is 6 into e to the power x plus constant of integration. So when you take e to the power x common, what you are getting here, x cube minus 3x square plus 6x minus 6. When you look at the given options, you can see, yes, option number 1 has the same result as we obtained here. Hence the correct answer is option number 1. Let's move on to the next one, that is question number 71. A relation P is defined on set of real numbers such that P is equal to x comma y, satisfying this equation. Then the relation P is, what we need to do? We need to simplify this equation. We need to see what is actual relation between x and y. So let's try this one. When you take x square common from the first two, you are left with x minus y in bracket plus 1 x minus y, the same factor. So clearly we have x square plus 1 into x minus y is equal to 0. That's clear. Now x square plus 1 obviously cannot be 0. So the only possibility is y is equal to x. Now when you say y is equal to x, simply identity, right? So clearly we can say this function is reflexive, because for each x you have the same value, so it is reflexive. This one is symmetric as well, right? So we can clearly redefine this relation as P equals x comma x such that x belongs to R. So clearly this function is reflexive, symmetric as well as transitive. So which one is the correct one? We can say this is an equivalence relation. Therefore option number 4 is the correct answer for this question. I'm sure this is clear. Let's move on to the next question now.